Hello everyone. Today we're going to continue lesson 5.4, which is on graphing polynomial functions. And we're going to take a look at some of the characteristics that will guide the graphs of the polynomial function. So we'll be able to sketch the graph of the polynomial in intercept form and then using leading coefficient test. So we're going to take a look at how the coefficient and the intercept form will help us to obtain the graph, like a general idea of what the graph looks like for the polynomial functions. And here we have the concept of the x-intercept. So in the past, you should have learned that an x-intercept is when the graph touches the x-axis. So for example, here are the x-intercepts. So wherever the graph touches the x-axis, that would be called or considered an x-intercept. So x-intercept, and another name for it is 0. Another word you might have heard of is called solution. These all mean the same thing. That means where does this equation function touch the x-axis. So just to give you a general idea, that those are the terms that refer to the same idea, the x-intercept concept. And so what are the factors? The factors are what causes or what will help us obtain the x-intercept. So the best way to look at factors is just to look at the different polynomials that are being multiplied together. So let's take a look at number 1. How many factors does each of the polynomial function have? So if you look at the function itself, which is x cubed, which just means x times x times x. Well, how many different factors are there? There's actually only one, because it's just the same factor multiplied together. So there's actually only one factor in this case, and that factor is x. And there is just, 3 of the same factor. So in this case, what is the solution that deals with this? Well, it's actually going to, we're going to get into that in the next slide. So let's just leave it at factor right now. So there's only one factor, and it's being repeated 3 times. So x is the only factor. So in this case here in number 2, we've got x times x minus 2. So we are just rewriting everything in a linear form. That's one factor. These just repeat. So that's 1 for the x, and then 1 of x minus 2. So we have 2 different factors. So in this case, there are 2 factors here. And in the third one, yes, you can see they all look different. So we got actually 3 different factors. So that's what a factor is. When the terms are multiplied together to get one polynomial function, they can be considered separate factors. And let's go ahead and try the next one. How many factors does this have? So you can go ahead and practice the screen just like on these problems, just like what we did previously, and then before you watch the answers. Hopefully you've had a chance to try the problem. So in this case, there are actually just one factor here. It's just being repeated 4 times. Here we got x times x times x, and then times x minus 2. So we've got actually 2 different factors. Here we got x times x times x minus 2, x plus 2. So we've got actually 1, 2, 3 different factors. And then here all of them are different. So we got 4 different factors. So hopefully you got them correct. Next, we're going to take a look at how to convert the factors now into the x-intercept concept. So a factor is just a number or a term that is being multiplied. But how do we apply that? Well, an x-intercept is, remember, when the graph touches the x-axis, right? So we're going to want to know, well, when is this going to equal to 0? Because that's what happens when we have the x-axis. Just means that y is equal to 0. So if we actually set this equation equal to 0 and solve and think what number would make this true. So the only situation would make this true is when x equal to 0, because then you got 0 cubed, which will give you 0. So the only case the only factor here, since the only factor here is x, and to make it 0, x has to equal to 0. So the solution here, or the x-intercept, is actually 0. And what does multiplicity mean? So earlier, remember I said that these factors are being repeated. So when we have a repeated factor, like for example, here we have 4 of the same thing. So we say that this is a multiplicity of 4. So the 0 here is x equal to 0. And then we have times 4. So we can say it's a multiplicity of 4. Okay, so that's what multiplicity is. And here we have two different factors, and it's x equal to 0. That would make that equal to 0 true. And then we have also x minus 2 equal to 0. If we set that equal to 0, we add 2. So we'll have a second solution, x equal to 2. And so there's actually a multiplicity of 2 for the 0, and there's a multiplicity of 1. So that's why total there are 3 factors here. Because if you add up the factors here, like here, there's a total of 3. So, oh, I didn't realize that I put, sorry, that's actually 3 here. In the previous problem, I did not see that. It's a 3. So there's a multiplicity of 3 in the previous one. Here for the x, there's a multiplicity of 2. And then for the 2, there's a multiplicity of 1. And here, if we set the equation equal to 0 individually, we will have the solutions x equal to 0, x equals 2, and x equals negative 2. Because when x equals to those values, 2 minus 2 will make it 0 here. Negative 2 plus 2 will make it 0 here. So that's why, and then 0 will make it 0 here. So that's why those are the actual solutions that would make it the equations true. So those are the zeros. And since here we only have one of each factor, all of them are just multiplicity of 1. And hopefully you know what an x-intercept and multiplicity is now. Go ahead and try these problems on your own, so that way you can practice the idea of x-intercept and multiplicity. Hopefully you've had a chance to try these problems before you look at the answers. So again, if we set them equal to 0, the only solution here will have x equal to 0, and that's a multiplicity of 4. And here, if we set it equal to 0, we will have x equal to 0 with a multiplicity of 3, and then x is equal to 2. So those are the two solutions here. And here we have, if we set it equal to 0, we have x equal to 0 with a multiplicity of 2. And then we got x equals 2 and x equals negative 2. So there are 3 zeros here. And then here in the last problem, if we set the equation equal to 0, we will have 4 different solutions or zeros, and they all are unique. So there's only a multiplicity of 1 for every single one of them. Usually we don't need to indicate the multiplicity of 1. If we don't write anything, it just automatically means there's only 1. Next, we're going to look at what is the concept of tangent versus a cross, the idea of a tangent and a cross. So just like the name, it's everyone should know what a tangent is. A tangent is when something touches the point at one point. Okay, so if this curve touches the x-axis at one point, that's called a tangent. Notice in the second example here, the graph crosses the x-axis. So it crosses the x-axis. So here is the x-axis, and it just crosses it. And so where it crosses is considered a cross, just like the name. So we understand hopefully what a tangent and what a cross is. So tangent versus cross. So again, if a graph touches barely the x-axis at one point, that's considered a tangent. If a graph just crosses, goes through, whether it's going up or down, as long as it crosses, it's considered a cross. So hopefully you know what that means, and we're going to take a look at the equations that will cause the graph to cross. So as you know, we have already explored what the cubic function looks like. So if we look at the x cubed function, remember the graph goes something like this, right? And notice that it crosses the x-axis at 0. So that's why the question is asking you, look at each factor separately. If it's odd, it crosses. So they're already telling you if the number here, the exponent is odd, it's going to cross. And then if it's even, it should be a tangent. So in this case, this is an odd number right here. So we can conclude that it crosses at x equal to 0. And then here we have an even function here, even x squared. It's going to actually be a tangent at x equal to 0. Remember, the factor is x equal to 0 and x equals 2, right? So at 2, since this is considered linear, which means it's odd, it should be a cross. So that's a tangent with a cross here. And here, each one of them is linear. So it's all just 1, 1, and 1. So they should all be what? Cross, right? Cross, cross, cross. And the zeros are 0, 2, and -2. And that's what they are here. So they are all crossing. So I'm going to give you a chance now to practice what we just said. And you're going to identify whether the function is going to be a tangent or a cross. Okay, so hopefully you can just pause the video and try the problem before you look at the answer. And so again, here we have x to the 4th, and we have, because remember, odd means cross. Even means tangent, right? So hopefully you remember that. Okay, so this is an even, so which means it's going to be a tangent. And tangent at x equal to 0, because the 0 is actually equal to 0. So here we have x cubed. So we're going to have, so it's an odd power. Odd means cross. So we're going to have a cross at, what's the 0 for that one? It's x equal to 0. And here, what's the 0? It's a single power, so it's an odd power. So that means it's going to be also a cross at x equals 2. And next, we're going to look at the next one is here we have x squared, which means even. So it's going to be a tangent at, at x equal to 0. And we're going to have a odd and odd. So we're going to have a cross at x equals 2. And also another cross at x equals -2. And last one is going to be, since they are all like single power, which means odd, x, 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 so they should all be cross. Cross, 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 cross at x equals 0, at x equals 2, x equals -2, and x equals -3. So that's how we can look at it. And hopefully now you know a little bit more about whether a graph is going to be a cross or a tangent. Remember, these are ways to help you guys to finally come up with the graph on your own. So now we're ready to take a look at the graph of polynomial functions and also other characteristics. So as we stated before, a polynomial function is just a graph that looks like either a linear, a line, or it could be a parabola, that's x squared, and then it could be a S shape, which means a cubic function, and then x to the 4th, which means like a W. This is x to the 4th, and then anything odd like 5th would be just looking like a shade of x cubed, and then anything even will be looking like a W. It's just a different shape of W. So that's so we want to clarify that for the graph of a polynomial, it's continuous. What does continuous mean? Continuous means when you actually just keep drawing, and then you don't lift up your finger. But if you have to lift up your finger and then take a pause, that would not be continuous. Notice here, it is not continuous. So if you look at the graphs here, they are all continuous. It does not stop. So that's what continuous means, okay? So this is not continuous right here. So continuous means it's smooth, and then there's no breaks, no holes, no gaps. So that's why it should be like, you should be able to draw it with one like stroke of a hand without lifting and your hand for the graph. The graph of a polynomial also has smooth rounded turns. There are no sharp turns. So you don't want to draw like, there are no such thing as like sharp turns for polynomial. So those are two things that we want to clarify. So when we're graphing polynomial, we always want to draw smooth, continuous curves, okay? Like these ones that are here. Investigating the leading coefficient. So remember, one of the objectives today is to look at the leading coefficient and see how that affects, right? So if you have an odd function, that means you have x, x cubed, x fifth, x seventh, blah, so on and so forth. or evens, x to the second, x to the fourth, x to the sixth. So anything that is odd, which is basically giving you like a general idea of how the graph is going to behave. So when you have an odd function, if the leading coefficient is positive, the graph will start to rise. The graph falls to the left and then rise to the right. So basically, if you have an odd function and it's positive, like coefficient, you're going to start increasing first. And then you're going to fall and then go up again. So basically, think of it as a positive means you're going up like a slope. You're moving upward. So, but then on the other hand, if it's negative, so if you have a negative x cubed, then you can consider your graph is going to be decreasing first and then going up and down like that. So that's how the difference between a positive and a negative. And then if you have, so that's why they're explaining it right here. So this side on the left is when the coefficient is positive. The one on the right is when the coefficient is negative. So you're going down first and then keep going, turns, depending on what kind of degree it is. So it falls when it's negative. So we got negative x cubed, negative x fifth, so on and so forth. So positive means going up and negative means going down. That's for the odd functions. For an even function, it's a lot simpler. So anything that is positive, so you got x squared, x fourth, anything positive, your curve or W shape or U shape, whatever it is, it's opening up, okay? And then for anything that is negative, so negative x squared, negative x fourth, your curve is just going to be opening down. So you got a sad face or generally just opening down, okay? That's how you can look at the general behavior for an odd or even. Now we're going to put this whole thing together and just come up with a general equation of how the graph looks like when we basically have just an equation based on the behavior of polynomial functions. How can we conclude or what can we say, the behavior of the graph is going to look like. So here we have y equals x to the third. So we know that there is a 0 at 0 or an x-intercept at 0 because that's the only factor, right? X is the only factor. So the only thing is x equal to 0. And we know that since this is a positive coefficient, it's going to start going up first. So if we follow the behavior, the general guideline that we have before that we studied, we know this graph is going to start increasing. And it's also going to be a cross at x equal to 0. So we know we're going to have to cross the x-axis at 0 and then keeps going up. So that's the general graph for, so there's a cross right there. It's for the x cubed. So let's go ahead and take a look at the second one. So we know that the zeros are at x equal to 0 and x equals 2. And since at x equal to 0, it's a square, we know that there's going to be a tangent. And then since this is an odd, so it's going to be a cross. So we have a tangent and a cross. And so let's go ahead and identify the zeros first. So at x equal to 0 and x equals 2. So those are the two zeros. So this is a positive coefficient as well because there's no negative sign in the front. And this is a cubic function. So together, remember 2 plus 1, this is a third degree. So it's x cubed. So it looks like the shape of an S or an N, right? So we're going to start increasing and then we're going to have a tangent at 0. So we're going to go up and come back to a tangent at 0, and then we're going to cross at 2, right? So we're going to go up and cross at 2. So that's basically how you can generalize the graph. The details may be a little bit different, like, this hump may be a little lower, but it should look something like this for the graph. And there's the zeros at 0 and 2, or the x-intercepts. Let's try one more. This is again, cubic function because there are 3x and all of them are odd. So we know that we have x equal to 0, x equals 2, and x equals negative 2. And since they're all odd, we have a cross, cross, and a cross. So we're going to cross in 3 places. So let's identify the zeros first. So we have 0, we got negative 2, and we got 2. So we know that each one of them is going to cross. And this is a positive coefficient as well. So we're going to start increasing. So we're going to increase at the first 0. So increase, cross, cross, and cross. So that should be what the graph looks like. So I want you guys to now go ahead and go into your decimals and then just enter these graphs separately, all of these functions, just the way you see them, into the graph, into decimal window, and just kind of like, test to see if that is what the graph looks like. And so you can go ahead and verify that we have something like this, the general behavior. And before we go on, so go ahead and verify. Hopefully you've had a chance to verify your answers, the graphs, to see that it matches what our generalization is. Now I'm going to give you a chance to practice graphing these ones to generalize by the behavior that we have. So go ahead and try these on your own first before you check the answers. And here's number 1. So the only 0 we have here is at x equal to 0, and since it's even, it's going to be a tangent. So we have a tangent at 0, and that's the only thing. And this is a positive, so it's going to be even. Even positive means it's going to be opening up, right? So we can have something like a tangent right here. And so this is what a x to the 4th look like. And you can go ahead and use your graphing calculator to verify. It should look something like this. In number 2, the zeros are x equal to 0 and x equals 2. And they're both odd, which means that they're going to be both tangents, right? So we have a 0 at 0 and 2. So here's 2. And then we're going to be crossing. So this is an even function, so it looks like it should be x to the 4th total, right? So it should be a W shape opening up. So we can kind of conclude that it's going to be crossing the 0. So we need to actually cross the 0 here. And then maybe we can go back and cross a 2. So it should look something like this. And you can verify with decimals right now as we go. And next one, we have the zeros are at x equal to 0. And since that's an even power, it should be a tangent. And then we should have at x equals 2 and x equals -2. Those are crosses because they are actually odd. So put it together, we have the zeros are at 0, 2, and -2. So those are the 3 zeros. And we're going to start with the, we know that at x squared at 0 is going to be a tangent. So it's going to be crossing at -2. So we're going to cross at -2, and it should be at x to the 4th again. So it's positive and should be opening up. So we're going to have cross, tangent at 0, and then cross at 2. So that should be what it kind of looks like. And finally, we have x equal to 0, x equals 2, -2, and -3. Since they're all odd and it's total x to the 4th, again, we should have the W shape for the x to the 4th function. And since they're all odd, it's going to be cross, 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 cross. So we're going to be crossing at every one of these zeros. So we got x equal to 0, 2, -2, and -3. And since this is a W opening up, we're going to be crossing, 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 and crossing. And it should look something like this. So please verify this with decimals so you can be familiar with what the actual graph looks like. Like I said, there may be little variations like how, lower or higher maybe the humps goes, but it should be something like what we have. And that is the end of the lesson for today. So go ahead and go to Google Classroom and get started with your work. Have a nice day. See you tomorrow.